You're looking at a graph of an ellipse, and you can see the equation over here. I put a variable for the major and the minor axis numbers, but you can see that I've got C set to be 16, which would make this point on the major axis 4, 0 and negative 4, 0. And this number D is going to be 9, which square root of that would make this 0, 3 and 0, negative 3. So what I want to show you is what happens when I make this number bigger. So I'm going to leave the 9 alone, but I'm just going to animate this and make this number C right here bigger. So as you can see, the ellipse is getting stretched out. The bigger this C number is, it's stretching along the x-axis. Okay, and now it's going to bounce back and it's going to retract as this number C gets smaller. Okay. So notice when this number is getting close to this number, it's pretty much looking like a circle. If both of these numbers were the same, we'd be looking at a circle. Okay, but the question is, what's going to happen when it goes into the negative realm? Okay, so this thing is shrinking down. Watch what happens when C becomes a negative number. Okay, check it out. That ellipse just turned into a hyperbola. This shape right here, this double, it looks like a parabola, but it's not quite the right relationship. But this shape is called a hyperbola. So let me run this. So you're stretching out that C number, but it's really, really negative here, up to negative 100 basically. And then as this moves closer to 0, it flips back into an ellipse now. And it's stretching out. It's an ellipse that's stretched out as long as this number is positive. In fact, both of these numbers are positive. But as soon as one of these numbers, in fact, this number is changing to a negative, it turns from that ellipse into a hyperbola. Okay? One thing I want you to notice that doesn't change. Okay? Look for what doesn't change here. Whether it's an ellipse or whether it's a hyperbola, you should notice that this vertex right here does not change, and likewise this one. So watch, we're at 0, 3. We still have a vertex at 0, 3 here, even when it changes to a hyperbola. So the y part didn't change here. This y number for my minor axis, it is not changing. But the x number is the thing that's getting stretched out. I know it's a lot easier to see when you're looking at an ellipse, but it's stretching in that x direction, and it's going to stretch in that x direction when it's a hyperbola as well. Hyperbolas. A hyperbola is the set of all points in a plane such that the absolute value of the difference of the distances from two fixed points is constant. The two fixed points are the foci of the hyperbola. You might remember with an ellipse, we talked about the sum of those 2 points. Now we're talking about the difference of those 2 points. Okay, so you might remember D1 plus D2. Now for a hyperbola, D1 minus D2. The difference is really that minus, and that's kind of a big deal. If you look at the formula, the equation of a hyperbola is going to look something like this. And you need to pay attention to the minus. Okay, that subtraction makes all the difference in turning this into a hyperbola instead of an ellipse. If that was a plus, that would be an ellipse. So one of the terms is going to be positive, and one of the terms is going to be negative. So you look at the one that's positive. The term that's positive tells you which direction that hyperbola is going to open up. So in this example, in this equation, it looks like it's opening in the x direction. Okay, you're going to have asymptotes. So you divide the a and the b numbers, okay? Divide the a and the b numbers, and you're also going to have foci. And foci, let's see. You're going to calculate the foci in a similar way to the ellipses. So you're going to have that formula for finding those foci points. Example 1, we're going to graph this one, and you can tell it's a hyperbola, not an ellipse. It looks an awful lot like it, but you can tell it's a hyperbola when you see that negative. The term that's positive tells me that this is going to open in the x direction, so you already know it's going to look something like this. We just need to nail down some specifics. So I can see that the A number is 5 and the B number is 2. We're operating just like we did with ellipses, okay? So if I'm going to graph this, we're going to graph this by hand, and I'm going to cheat a little bit. Draw your axis and your tick marks by hand, and you have to notice which direction this thing opens. You have to. So in the x direction, we're going to go over 2 from the center. Notice you can tell right away that the center is 0, 0. So we know the center of this thing is 0, 0. I don't need to graph that because technically that's not part of the graph. We just want the curved part. So we go over from the center 2 in the x direction. And those are going to be my vertices. All right, but we also would need to go 5 in the y direction. So those are the, I don't want to call them vertices, but those are also important points. Here's where it gets kind of weird. What we have to do is we have to draw kind of a box. That is not part of our graph, but that's just what we're going to use, okay? So we've got that box, and then we've got to draw some asymptotes. The asymptotes are going to be from corner to opposite corner of the box. So it's going to look something like this. Let me move that. Okay, there's one, and there's the other. Okay, that's what we need in order to draw those things. So what we've got then, our hyperbola is going to have this vertex, and we're going to draw a curve that curves around and approaches those asymptotes. Looks something like this. Okay, that's what this thing looks like. Now we can find the foci. I know it didn't ask me to, but we can find the foci points. A squared was 25 and B squared was 4. So that's C squared equals 29. Square root is going to give me a distance of square root of 29. And so square root of 29 is going to be about 5 point something, okay? About 5 point something should be, I don't know, here-ish, and negative here-ish. So again, it's on that major axis, but those are your foci points. The points themselves would be square root of 29, comma 0, and negative square root of 29, comma 0. So we've got the graph, we need to give the domain and the range. Okay, so try to ignore all the other noise and understand that the answer, or the graph, is red. Okay, so if you look at just the red part, for the domain, squish it onto the x-axis. All right, and if you squish it onto the x-axis, we're talking about there. All right, so we are talking about going from negative infinity to negative 2 inclusive, unioned with starting back up again at 2 to positive infinity. If you look at the range, you should know this, but the range, the y values are covering everything. So range is going to be all real numbers, negative infinity to positive infinity. Example 2. We need that 1, so we're going to end up having to divide by 400. So we divide each term by 400 and reduce the fractions. Once you do this, 16 goes into 425 times. So we'd have y squared over 25 minus x squared over 25 goes into 416 times equals 1. Okay, so that's the form that's going to tell us something. Since the y term is the positive term, this tells me that we're going to go in the y direction. So we can see that a number is 5 and the b number is 4. So we're going to draw this. I'm going to draw this thing in here. Okay, so that 5 number is going in my y direction, in my positive direction. So let's graph that vertex. And then the 4 is going in the other direction, in the x direction. Those aren't really vertices, but that's what I'm going to use to draw that box. So let's draw that box in there. Okay, and we will also draw the asymptotes. All right, so now we have kind of our guidelines. We have our guidelines for the parabolas, and now we can just sketch the curves in there. So we know that it starts at this vertex, and it's going to approach but not cross these asymptotes. Looks something like that. So if I have to find the foci, again, the foci, c squared equals a squared plus b squared. So that's going to be 25 plus 16 is 41. C equals square root of 41. So square root of 41, we would go, what is that, about 6 point something? So we'd have to go, the foci is going to be up here somewhere. 6 point something, negative 6 point something. Your coordinates would be the points 0, comma, square root of 41, and 0, comma, negative square root of 41, because we're in the y direction this time. Also, we want the domain and the range. You look at the domain, the x numbers. It's going to be all real numbers. The range is the tricky one this time, because if you look at your y's, you're only going here and here. So pay attention to that. And we're going from negative infinity all the way at the bottom up to negative 5, inclusive, unioned with from 5 to infinity. Example 3, we look at this one and we can see the center this time is a little bit different. So this one has to be handled a little different. The center is at 2, comma, negative 4. So you have to remember that when you draw your curve, when you draw your graph, you're going to have to shift everything over so that the 2, negative 4 forms the center. We look for the positive term, and the positive term is the x term, and that tells me that this is going to point in the x direction. So let's graph that 2, negative 4. 2, negative 4 is going to be around in here somewhere. Okay. I guess we didn't really have to graph that, but that's the center point of everything that's going to happen. Okay. So you notice that this number is 1, and so you should be able to see that the a number is 4 and the b number, square root of 1, is 1. So since we're going in the x direction, you would need to go over 4 in either direction. So it looks like we would need another tick marker. So there's 1. Okay. And we're going to need a couple going down too, I believe. So if we go over 4 in the x direction, from the center, 1, 2, 3, 4, we would be about right here. And in the other direction, 1, 2, 3, 4, we'd be about right here. And then we only have to go up 1 or down 1 in the y direction. So if we draw in our box and our asymptotes, we should be able to draw our curves. It looks something like this. Make sure you don't cross that asymptote. That one's better. Okay. The foci, if you find the foci, c squared equals a squared plus b squared. That's going to be 16 plus 1, so we're looking at c squared equals 17, c equals the square root of 17. That's going to be, well, it's going to be about 4 point something away from the center. So it's not going to be at the coordinate square root of 17. It's going to be square root of 17 over from the center. So it's going to be in there somewhere. Okay. We have to give the domain and the range. Domain, the x numbers, going from negative infinity to, it looks like negative 2, inclusive, unioned with this vertex point is at 1, 2, 3, 4, 5, 6, going to positive infinity. As for the range is going to be all real numbers. Eccentricity of a hyperbola. We still have that same formula from the last section, E equals C over A, where C is that distance to the focus and A is the larger of the distances. Narrow hyperbolas have E, an E value near 1. The larger E is, the wider the hyperbola. So you can see this one is kind of narrow and its E value is kind of by 1. This one has a rather large E value of 5 and it's a really wide one. Example 4, find the eccentricity of the hyperbola given there. So we know E equals C over A, and we can't really see some of those numbers. We would see that A equals 10 and B equals 9 from this. And so we have a formula for hyperbolas that says C squared equals A squared plus B squared. A squared being 100, B squared being 81, C squared is going to equal 181. So C equals the square root of 81. So if I plug this in, the eccentricity is going to be C over A, that's the square root of 181, over your A value, which is 10. And plug that into a calculator, you're going to get about 1.3. Eccentricity, 1.3. Example 5, find the equation of the hyperbola with eccentricity 3 and foci at negative 2, 5 and negative 2, negative 3. Okay, so there's a lot going on here. We have to find that equation. They tell me that the eccentricity is 3, so I start off and I know I have this formula right here. But they give me that the eccentricity is 3, but I don't know the C value or the A value. They do give me kind of a description of what this looks like. So what I might do is try to imagine what this looks like and what these points are doing. So if I go to the first focus point at negative 2, 5, 1, 2, 1, 2, 3, 4, 5. I know there's a focus point right there. And negative 2, negative 3. There's a focus point right there. All right. So basically what I can determine here is that the center is going to be in the middle of that. So if I go 1, 2, 3, 4, or 1, 2, 3, 4, the middle, the center is at that point negative 2, positive 1. Okay. So I know that my formula is oriented in the y direction. My hyperbola is oriented in the y direction, so that means the y part's going to be first. It's going to be y minus 1 squared over something minus x plus 2 squared over something equals 1. So I don't have that over something. I need the a and the b value. Well, in this picture that I've drawn, you can see that that distance is 4, and that's your C value. The C value is the distance from the center to the focus. So 4 in either direction. So I know the C value is 4. So I can come over here to my formula, and I should be able to find the A value. Cross multiply to get that variable off the bottom. 3A equals 4 divide by 3, a equals 4/3. A equals 4/3. So if you square that, a squared is equal to 16/9, and that's what goes right here, 16/9. Now that's a little bit weird to have a fraction on the bottom of a fraction, so we'll take care of that here in a second. We need to find the other value, the b value, and so we're going to use that c squared equals a squared plus b squared formula. C squared, 4 squared is 16, equals a squared, that's your 16 over 9, plus b squared. So we need to solve this, so subtract that 16/9 over. You've got to do 16 minus 16/9. I'll let you do that on a calculator. 16 minus 16/9 is 128/9. 128/9. So you could do the square root and find what b is, but actually I don't really care what b is. I need the b squared value. B squared is 128 over 9, and that's what goes on the bottom of that fraction. Okay, we are almost finished. The only thing you have to consider is fraction divided by fraction, which is what we have. If I'm dividing a fraction by a fraction, I multiply by the reciprocal. So if you just multiply by the reciprocal, you would take this number on the top and multiply by 9/16. You're going to get 9/16 times y minus 1 squared. So essentially you're just flipping that fraction. 9x plus 2 squared over 128 equals 1. There's your equation. So then the last little bit here just kind of sums up some eccentricities. Eccentricity of a parabola is 1, of a circle is 0, an ellipse is going to be in between 0 and 1. The closer to 0 it is, the closer to a circle it is. Okay, and then a hyperbola, the eccentricity is going to be bigger than 1.